Welcome back to the online course, Road Subgrade and Pavement Engineering. My name is Peng Li. Let's continue on the topic of concrete pavement. In today's lecture, we will finish the last section, concrete pavement design. Before we evaluate a concrete pavement structure, we have to propose a candidate pavement structure. General considerations are listed below. More layers and higher strength of materials is required for roadways with heavy traffic load. And if the traffic is light, less layers and materials with lower strength are needed. Weak subgrade should be improved or treated to meet the requirement. Permeability of the layer may impact drainage of water and further result in water-related damage. Binding between layers may result in damage of joints or cracks of concrete slab. This table lists recommended thickness for different traffic levels. When traffic is extremely heavy, the minimum thickness of concrete slab is 32 centimeters. At the same time, the variance of materials is also low. As traffic level decreases, the thickness of concrete also reduces. When the traffic level is light, the minimum thickness of concrete slab is only 18 centimeters. The variance level can be high or moderate. The selection of base and subbase is also determined according to traffic level. As shown in the table, lane concrete, road concrete, and asphalt concrete could be used as the base for extreme or very heavy traffic. As traffic level decreases, the light bound or even unbound materials could be used for base or subbase. All concrete slabs have to be rectangular. Spacing of longitudinal joint is about 3 to 4.5 meters. Tie bar should be used. Spacing of transverse joint is about 4 to 6 meters. Dowel bar should be used. The ratio of transverse spacing to longitudinal space has to be less than 1.35. For plain concrete, the area of a slab has to be less than 25 square meters. Transverse and longitudinal joints should be perpendicular, and the transverse joint along a longitudinal joint should be in line. Now, let's move to the thickness verification. First, we need to determine the load-induced fatigue stress for single-layer plate system on elastic foundation. As shown in the equation, sigma PR equals to KR multiplied KF multiplied KC multiplied sigma PS. Sigma PS is the critical stress of concrete slab with 4 free edges under one cycle of the design actual load. I will show you how to determine it in the next slide. KR is the stress reduction coefficient considering load transfer. For concrete shoulder, the value is between 0.87 and 0.92. For asphalt concrete or soil shoulder, the value is 1. KF is fatigue stress coefficient. The equation used to calculate is shown here. The value of KF relates to the design traffic level. Higher the traffic is, higher the value of KF will be. And KC is the correction coefficient considering differences between theoretical and practical conditions. It is determined according to the level of roadway. This flowchart is the procedure to determine the sigma PS. First, we need to calculate ET based on granular layer thickness and modulus, regression coefficient, and subgrade modulus. Next, according to modulus and thickness of concrete slab, we can determine the value of DC. Combined with the value of ET, we can obtain the value of relative stiffness radius, R. And finally, we use this equation to calculate the sigma PS. The method used to determine the load-induced maximum stress is similar to the fatigue stress. Sigma PS is replaced by sigma PM. Calculation of sigma PM is same as sigma PS, except using the maximum load instead of the standard load. And in this equation, only stress reduction coefficient and correction coefficient are included. Equation used to calculate the maximum thermal stress for single layer plate system on elastic foundation is shown here. Inside the equation, Tg is the maximum temperature gradient in the past 50 years. The fatigue thermal stress is calculated by multiply Kt to maximum thermal stress. Kt can be determined using this equation. Value of three coefficients, alpha t, bt, and ct, can be found in this table according to the natural zone. And finally, we're going to evaluate the thickness using the following two criteria. The first one, to combine effects of the load-induced fatigue stress and the thermal fatigue stress. The second one, the combined effect of maximum load-induced stress and the maximum thermal stress. If the initial structure meets all criteria, the design is completed. Otherwise, the slab thickness or foundation should be redesigned. And that's all for concrete pavement. Thank you for listening.